The heat wave is not over. Let that sink in first, because what is about to happen is being misread by almost everyone following the UK's extraordinary week of record-breaking temperatures. The narrative that has taken hold, heat arriving, heat breaking, weather returning to normal, is wrong. And it is wrong in a way that matters enormously for every person living in the path of what is coming next. The breakdown of the blocking high-pressure system that delivered the UK its hottest May day in recorded history is not the end of the weather story. It is the ignition point for something that the Met Office has classified with a rare amber weather warning, a designation applied to thunderstorm events infrequently enough that most people in the affected areas have never experienced one in a weather context before. 30 to 40 millimeters of rainfall in 30 minutes, 60 millimeters in an hour in some locations, lightning, large hail, strong destructive winds, flash flooding on ground that has been baked to the hardness of concrete by days of 30 to 35 degree heat, and weeks of the driest spring in 132 years. This is the storm nobody is ready for. Not because the warning has not been issued, but because the conditions that make it uniquely dangerous have never previously arrived in this combination at this time of year in the UK's modern meteorological record. The Met Office's amber weather warning for thunderstorms is the specific piece of official communication that defines the scale of what is building. The amber warning applies to parts of the East and West Midlands, and the East, Southeast, and Southwest of England. It is valid until 7 p.m. on Monday. Forecasters describe the mechanism with unusual specificity. A cluster or line of very active thunderstorms is moving towards the northwest from Bedfordshire and Buckinghamshire towards the West Midlands. These will bring a period of exceptionally heavy rainfall, 30 to 40 millimeters falling in around 30 minutes, perhaps around 60 millimeters in an hour for some locations. A yellow weather warning was simultaneously issued for large parts of England, including London, Oxford, Nottingham, and Manchester, with further alerts for Scotland and Northern Ireland. The Environment Agency responded immediately by issuing 14 flood alerts across the Midlands, a rapid multi-authority activation that reflects the specific recognition that the ground receiving this rainfall is in no condition to absorb it. When 14 flood alerts are issued before a storm has even arrived, the water resource agencies managing those river catchments are telling you something specific and important about what they are expecting. The rainfall to due to a landscape that has had no meaningful precipitation in weeks. The atmospheric physics of what happens when a blocking high-pressure breakdown meets an unstable, humid air mass is the mechanism that produces the specific violence of post-heat wave thunderstorms, and it is a mechanism that is directly amplified by the intensity of the heat event that preceded it. During the record-breaking peak days, the atmosphere over southern and central England absorbed enormous quantities of solar energy through the clear, cloud-free skies that the blocking high created. That energy went into heating both the land surface and the lower atmosphere. Moisture from the soil, from vegetation, from open water bodies and reservoirs evaporated into the air mass sitting above Britain, loading it with water vapor at rates that warm, stable conditions allow. The atmosphere became simultaneously hot, unstable, and moisture-laden, the three ingredients that, when the cap provided by the high-pressure system is finally removed by an incoming Atlantic front, produce explosive convective development. The incoming Atlantic air acts as the trigger. The energy and moisture loaded into the air mass during the heat event provides the fuel. The result is thunderstorm development that is faster, more intense, and more electrically active than ordinary summer storms, because the thermodynamic environment they are developing in has been supercharged by the preceding heat accumulation. 30 to 40 millimeters in 30 minutes is not a normal summer storm. It is a heat dome breakdown event, and the intensity of the breakdown is proportional to the intensity of the heat that preceded it. The 60 millimeter per hour rainfall rate that the Met Office flagged as possible in some locations deserves to be translated into practical consequence, because that number is abstract until you understand what it means for a real drainage system in a real town on real baked ground. 60 millimeters per hour is the rainfall intensity of a tropical downpour. The drainage infrastructure of English towns and cities, the gully pots, the culverts, the combined sewer networks, the road drainage channels, were designed and sized for the rainfall intensities of a normal British summer. Normal British summer intense rainfall produces 10 to 20 millimeters per hour in the most significant events. 60 millimeters per hour overwhelms those drainage systems within minutes of the rain beginning. Water that cannot enter the drainage system accumulates on road surfaces, in underpasses, in low-lying ground, in basements with inadequate flood protection, and along natural watercourses that receive the runoff from the hardened, impermeable urban surfaces much faster than they can convey it downstream. The Environment Agency's 14 flood alerts across the Midlands are the advance signal that exactly this process is anticipated to occur across multiple river catchments simultaneously. Flash flooding events of this character have no warning time measured in hours. The water rises in minutes. And the people caught in underpasses, in ground floor properties near watercourses, or in vehicles attempting to drive through flooded roads are in danger before any emergency service response can reach them. The hail threat that accompanies the thunderstorm warning is a dimension that the media coverage consistently underweights relative to the flooding risk, but that carries its own specific danger profile. Large hail. The Met Office's warning language references the hail hazard alongside lightning and strong winds, forms within the intense updrafts of supercell or quasi-linear convective system thunderstorms. The same thermodynamic energy that produces 60 millimeter per hour rainfall also drives the updraft velocities needed to suspend large hailstones in the upper regions of the storm before they fall. In post-heatwave breakdown events across Europe, hailstones reaching 3 to 5 centimeters in diameter, golf ball size, have been documented, causing damage to vehicles, breaking greenhouse glass, destroying crops, and injuring people caught outdoors without adequate shelter. The June 2024 European post-heatwave breakdown brought hailstones to Germany and Switzerland that destroyed power lines and damaged roofs extensively across entire districts. A June 2013 hailstorm in Germany caused insured losses exceeding 3 billion euros in a single event. The crops across the Midlands and East Anglia that have spent the past week managing heat and drought stress face a compounding threat from hail damage that arrives on top of that existing vulnerability rather than in isolation from it. Agricultural insurance claims, following large hail events and already stressed cropping seasons, can reach levels that push some farm businesses into financial crisis, and the timing of this event, with winter wheat in its critical grain-filling stage across the East Anglian counties, places the hail risk at the highest consequence point in the crop's seasonal calendar. The European context of what is happening to the UK is the wider frame within which the rare storm needs to be understood, because the same high atmospheric boundary that is producing the thunderstorm amber warning in England is simultaneously active across a much larger geographic area. The June 2026 weather outlook from Pogodnik's analysis was explicit. June 2026 may bring dry, pressure-dominated spells under the heat dome, but also sharp thunderstorm outbreaks along its edges. The edges of a heat dome are precisely where the most violent convective activity concentrates. The boundary between the stable, capped warm air inside the dome and the cooler, more unstable air outside it is where the atmospheric energy gradient is steepest, and where convective initiation is most explosive when that boundary is disturbed by an incoming Atlantic system. France, Germany, Benelux, and the northern edge of the heat dome's extent are simultaneously in the storm corridor that runs along the dome's periphery. The 2026 European Storm Training Event, a rare phenomenon of consecutive, severe meteorological depressions affecting Portugal, Spain, France, Italy, and the United Kingdom beginning in January 2026, with wind gusts reaching 208.8 kilometers per hour at Sour in Portugal, and 16 fatalities, demonstrated earlier in the year how organized the European windstorm season had become in the context of increasingly volatile atmospheric transitions. The thunderstorm breakdown now unfolding is a different atmospheric mode from the winter windstorm season, but it is rooted in the same fundamental dynamic. Extremes at one end of the atmospheric spectrum, generating extremes at the other end as the energy stored during the heat event is released. The wildfire dimension of the rare storm's aftermath is one that typically surprises people unfamiliar with the specific sequence of events that follows a post-heatwave breakdown. During the heat event itself, particularly in the final days before the breakdown when the UK recorded its hottest May temperatures, grass fires broke out across multiple locations, including the widely reported fire near Arthur's Seat in Edinburgh that sent smoke drifting over the Scottish capital. Dried vegetation across the Midlands, East Anglia, and the southeast had reached moisture content levels comparable to mid-August in a normal summer. The thunderstorm breakdown brings lightning before it brings significant rainfall, and lightning strikes on drought-stressed, tinder-dry vegetation are a documented wildfire ignition mechanism. The dry lightning risk that precedes the main rainfall is the specific meteorological phenomenon where lightning reaches the ground in advance of the precipitation that would normally dampen the fuel below it. Fire services across the affected counties have been operating at elevated readiness since the heat event began. The combination of dry vegetation, active lightning, and fire services already stretched by the heat event creates the conditions for wildfire ignition during the storm's lightning phase before the rainfall arrives to suppress it. The river system response to 60 millimeters of rainfall per hour on drought-hardened ground extends beyond the immediate flash flood risk into a longer-term water quality and ecological impact that is documented but rarely discussed in real-time storm coverage. When intense rainfall hits baked, compacted soil, the water that cannot infiltrate runs off across the surface, collecting agricultural runoff, pesticide residues, fertilizer compounds, fine soil particles, and urban pollutants, road oil, tire particles, heavy metals from brake dust, and transporting them rapidly into watercourses that are already thermally stressed from the heat wave's direct warming of river water. The oxygen content of those rivers, already reduced by the elevated water temperatures of the preceding heat event, faces a further reduction from the sudden influx of organic matter and agricultural chemicals that surface runoff delivers. Fish kills, documented across multiple UK rivers following the 2022 and 2025 heat and storm sequences, are more likely in rivers that have been thermally stressed before the storm than in rivers receiving the same rainfall under normal temperature conditions. The Environment Agency's 14 flood alerts are managing the immediate flood risk. The water quality and ecological damage that follows the storm will take weeks to assess and months to recover from across the river systems of the Midlands and East Anglia. The psychological unpreparedness that the title of this piece references is real and specifically documented in emergency management research on post-heatwave storm events. People who have spent a week enjoying warm, sunny weather do not transition easily or quickly into the mental state of hazard awareness that an amber thunderstorm warning requires. The bank holiday and half-term context that accompanied the UK's record-breaking heat event means millions of families are in outdoor leisure mode, at campsites, at beach destinations and parks, at sporting events, precisely when the storm warning activates. The RNLI's data on drowning incidents during hot weather bank holiday weekends shows that the combination of large numbers of people near water and the sudden violent weather change that post-heatwave storms produce creates a specific and acute danger window. Lightning strikes on open water and open ground are the obvious hazard. Less obvious is the flash flood risk in coastal areas where watercourses draining inland toward the sea can rise rapidly, cutting off routes and overwhelming beach car parks and low-lying areas. The 14 Environment Agency flood alerts across the Midlands are the formal system's advance warning. The informal warning that everyone in the amber and yellow zones needs to act on right now is simpler and more direct. Move to safety before the storm arrives, not after you can see it on the horizon. The transition from the record-breaking heat to the rare storm is also a health transition that the public health communication around this event has not yet fully pivoted to accommodate. The UKHSA's Amber Heat Health Alert remains active. The Environment Agency's 14 flood alerts are new. The Met Office's thunderstorm warnings are overlapping with ongoing heat advice. The multiple simultaneous alert streams create a communication environment where different messages compete for the same limited public attention, and the population that has spent a week managing heat advice, windows closed, blinds drawn, avoid outdoors at peak heat hours, needs to simultaneously shift to storm advice. Avoid the outdoors during the storm itself. Do not shelter under isolated trees or near metal structures. Do not attempt to drive through flooded roads regardless of apparent depth, and recognize that the lightning risk is real, measurable, and immediately life-threatening. Standing water on a road surface that appears shallow is consistently the most lethal decision point in flood events. 30 centimeters of fast-moving water can knock an adult off their feet, and 60 centimeters can carry a vehicle off course. The majority of flood fatalities in UK urban flash flood events involve vehicles attempting to cross flooded roads. The amber warning is not administrative caution. It is a specific, evidence-based communication that the conditions building behind this rare storm are capable of producing life safety events across a wide area simultaneously. A single lightning event can deliver 30,000 amperes of current. The storm system now tracking toward the UK from the south and east will produce thousands of lightning strikes across the amber zone before the evening is out. Nobody is ready for it. The warning has been issued. The readiness is everyone's to choose.